It's great to see you all. I'm very happy to be straight after lunch when you're all freshly nourished.
Do you know how to work this
and
thing?
ready for a bit of...
Yeah, I thought so. I've been trying to push it.
Ja, vi talar om det. Tack.
So it's not working.
Probeer maar eens.
If you go slideshow back, let's see. So we don't have the PDF, do we?
It doesn't go full screen?
No. No, it doesn't.
Oh.
What is this? What if you close it and restart it? Or are they all like in a row? There we go. And then if you... So, okay, now it, yeah. Close and start. So,
Or you can use these ones.
yeah. And then you have
Hello. Hello, everyone. So I'm Anna, sorry for missing in the introduction. Really happy to be here with you today. So we, Anna and Jan, and we're from Lúdika Arkitektar, and we're here to tell you about our hempcrete adventure. Maybe I'll tell you.
Yeah.
As with most stories, it makes sense to start at the beginning. My partner Jan and I have been living and working in London for almost a decade when COVID hit. We moved back to Iceland, in my case back home, and arrived on the island fresh-eyed, seeing and learning what the norm was in the Icelandic construction industry. And what we discovered was quite unnerving. First of all, nearly all building material is imported to Iceland. Secondly, the majority of buildings in Iceland are made of concrete, one of the most destructive materials on Earth. Now, as architects, we're already gravely aware of the part the construction industry plays in terms of carbon emissions. This will all make sense in the long run, talking about the problem with the industry. So the industry is responsible for nearly 40% of global carbon emissions, which is a huge amount. So definitely scope to change things here. In Iceland, building materials account for almost 45% of carbon emissions from building materials alone. And here we're talking about concrete mostly being the culprit. And then it's all the waste. So much building waste ends up in landfill or is simply burnt. I mean, these are huge numbers. To put things into perspective, we have effectively already reached a point in time when human-made materials outweigh all the living things on Earth. And you can see the green bit is concrete. And yes, I know I keep banging on about concrete, but for good reason. Concrete is an amazing building material, but we are just simply using far too much of it and not thinking about how best to utilize it. Did you know, for example, that the only other substance that we use more than concrete is water? So concrete is the second most used substance on Earth. That's how much we use. And a big part of concrete, as you know, is sand. And we're using so much that sand has become, it's basically, we are running out of sand. And I think that's pretty serious because sand is also what we use to make glass, silicone, and so on. Sorry. And we're already seeing the sand scarcity effects in Iceland, where there are plans to move mountains and beaches across the Atlantic to make environmentally friendly concrete. So this all paints a pretty bleak picture, but that's exactly the point in time when the story turns to plants. Using bio-based materials is, of course, not by any means a new thing. For centuries, the traditional way of building in Iceland was using driftwood, turf, and stones. Turf houses, basically. We used what we had here on the island. It wasn't much, and the living conditions weren't the greatest, but it sustained the nation for nearly 1,000 years. So when we learned in 2020, when we moved back to Iceland, that it had just become legal to import and grow industrial hemp in Iceland, thanks to the tireless efforts of the Icelandic Hemp Association, an idea was born. We moved forward in time, about a year and a half, and we had received our first grant to design and build a small prototype hempcrete building, which would become the first of its kind in Iceland. And just to mention the grants we got at the bottom. So after we got the first grant, one of the first steps was simply to get in touch with the Icelandic Hemp Association. And together with Tóta, a few months later, because things can happen really fast in Iceland, the seeds were in the ground. The idea being to use the harvest to assess the yields and then ultimately use the harvest to build this first prototype. So that's from Sandhóll in 2022. A few months later, we hosted a hempcrete workshop, also together with Icelandic Hempcrete Association. We got Professor Tom Woolley to come and teach us all about hemp and mixing. And this served to give us some proper hands-on experience with the mixing and casting of hempcrete. And also was great to see the interest in the material. So the turnout was great. And yeah, interest proven. But I know some of you might not be fully aware of what exactly hempcrete is. So let's give you a bit of better idea about that. So hemp is the second fastest growing plant in the world after bamboo, which means that it binds carbon really effectively from the atmosphere. So as you can see, 1 hectare of industrial hemp sequesters 9 to 22 tons of CO2 per year compared to woodland. We have nothing against woodland, but it's just to show you how effective the plant is in binding carbon. The part of the plant that is used for hempcrete is the hemp sheave, the inner bit in the woody core, which is the majority of the plant. And which was traditionally a byproduct or not even used at all, or maybe as bedding for animals. And usually it was the more precious fibers that were used. And the makeup of hempcrete is endearingly simple. It's simply the hemp sheave, water, and a binder, which is usually lime-based. Hempcrete, as a building material, is non-load-bearing, so it requires a structural frame to do the heavy work. And as such, it's easiest to classify as an insulation material, though in reality it is a lot more than that. In its simplest form, it can be cast straight into formwork, and you can see the structural frame in the middle. And then it can be prefabricated as blocks or timber cassettes, which aids production speed and quality, and also would be great for Iceland when we have lots of different weathers. So if we can just do it inside, that would be helpful. full. It can also form external walls, internal walls, insulation to roofs and floors. So it can be used for a lot of applications. In terms of its performance as a building material, it's breathable, meaning that water vapor can travel through the walls with self-regulating its moisture content. This means that the hempcrete shell keeps the humidity of the air inside the building stable, regardless of what's happening outside. And this has been proven time and time again. It's mold resistant due to the lime content, which also means that it's fire resistant. It has excellent acoustic qualities, and we experienced that ourselves, which we can come back onto later. But most importantly, it sequesters carbon from the atmosphere as a building material. So not only is the plant binding carbon from the atmosphere, but the building material too. So it's one of the few carbon negative building materials that are available. Plus, another good thing is it has thermal mass. So, for example, what we are more familiar with in Iceland is rockwool, steinull, which doesn't have thermal mass. But it basically means that it stores heat in the walls and then regulates the temperature inside more effectively, which you don't really see in the performance spec, but that's maybe being too technical. And yeah, last but not least, at the end of its life, it can be broken down and used as fertilizer on agricultural land. So hempcrete is really the building material that, if we grow it locally, could shift the construction industry from being completely import reliant and polluting to a more sustainable and regenerative reality. Because at the upper bit is the current situation, and this is what we hope the future can be. And that's what we're hoping to prove with a little prototype.
Yes, and now that we know a little bit more about hempcrete, I would like to tell you more of the story of our little prototype. So the key elements that we wanted to address in this project was crucially behavior of hempcrete as a building material in a building in Iceland, given Iceland's very particular climatic conditions. So this mainly is to do with the temperature and humidity fluctuations, the freeze and thaw, and how the building material would react to it. So having this idea from the outset, we were very excited about it, but the only way to actually see it in action and to test it was to do it ourselves. Yes, so within this is obviously the air tightness, the external finishes, how it would, again, react to the rather serious conditions that we get on the island. Its durability, as well as doing it in situ, so doing it on site, doing the sort of the low-tech approach and seeing how that would perform. So we set ourselves some key parameters. So as one, to use as many local materials as possible, sort of reduce our reliance in part of the wider philosophy on imported materials. Have a minimal intervention in terms of the site of the building. So this is obviously a rural location. So we wanted for it to have a minimal imprint on the ground. Almost a reversible sort of approach, a small scale. So given that the current building regulations are rather restrictive, the way to do it with this material was to follow the Smáhisi, where you don't need a full building application sort of approval, which limited the building to be 2.5 meters high and 15 square meters of built footprint. And then the design was driven in part due to its size by the concept of a Japanese tea house. So a small humble building connected to nature. And kind of the key features that come with it is the little door. So traditionally in Japanese tea houses, you would, as a samurai, you'd leave your swords behind and bow down and enter and leave your ego behind as you entered the house. And within it, we framed the key views. So the big window over there sort of framing the west view towards Ingolsfjall, the local mountain, and the sort of mossy terrain around, and a bigger door to the north of the building, which framed a little wooded area. Yeah, and obviously the key part and driver was knowledge sharing. So how, through our experiment and the process and the learnings that we take from it, share this knowledge amongst people and the wider construction industry in hope of making this a reality. So in terms of the materials, key materials used, and the local materials, we used pumice from a local mine, which is commonly used in the area for sort of the hard landscaping. Poplar timber sourced from the east of Iceland, from one of the only functioning sawmills in the country, and it being one of the first cases of local poplar timber being used in, as a structure, on a structural basis, as the main frame of the building. Seaweed, to use in our experimental shoji screens, again inspired by the Japanese approach. More on that later. Large shingles, which were sourced from the north of the country, from Akureyri. So again, local material and an age-old building technique that hasn't been used much. Rock wool, in this particular case, because we're so limited by the height and the restriction that we had to economize on every millimeter, basically. And of course, rock wool being a locally produced material using green energy, so in the Icelandic case being quite good. And lastly, locally prefabricated foundations, which are from the Reykjanes area, and again, mostly used on smaller structures, but quite cleverly designed. So in a case of a building like this, the key part structurally is with the winds, not for it to sort of float away. And the way these foundations are designed is they are quite good bearing-wise, so they anchor the building into the ground. So, having set upon this journey, we needed joinery and carpentry skills, and for that, we could not think of a better way than to call on the help of the Wandergesellen. Wandergesellen are traveling journeymen, coming mostly from Germany, but there's different countries, Scandinavia and France as well, where this tradition continues. And I was lucky enough to have an old friend who used to be one, so we were able to reach out for some help. And at one of their gatherings, the idea was floated that there is a project in Iceland that might need help, and 3 of these lovely young men were very happy to come. So we have here Elias, Basti, and Georg. And just to give you a bit of a background, the Wandergesellen they are different trades, they are different craftsmen. They are masons, they are carpenters, they are joiners, they can be bakers, they can be brewers. And they, upon completing their training, they set off on a journey of 3 years and 1 day, minimum, where they cannot go within a 50-kilometer radius of their hometown. And the whole idea is to learn on the journey and meet other cultures and other trades and enlarge their minds. So this tradition dates back from the medieval ages, but these days, most of these schachts, as they're called, there are different associations, late 19th to early 20th century. Our friends were from the Freedom Brothers, hence they wear the red ties. That's how they identify themselves. And they travel with 2 sets of clothes, one that they have on their backs and one for working in. Everything is full of symbolism. They have these canes. They only travel with their tools. They basically travel for shelter and food and beer. And they have here, this is the flag. It's what they call the Charlie, which are different sort of embroideries that they do connected to different journeys and adventures that they had, and then they passed them on between themselves. So this was the flag that identified our project. And it was amazing working with them. We became very good friends in no time. We shared knowledge, we discussed the past, the present, and the future of the construction industry. And it was an amazing experience from the beginning to the end. And I hope that they, as we did, left feeling much enriched. And they certainly did have many adventures here in Iceland, but I could talk for ages about this. But yes, it was an adventure. And as it happened, so they knew this was a hempcrete building before they came here. None of them had worked with it before, but by chance, one of them had actually, just before coming to Iceland, found work on a building site in Bavaria, in northern Bavaria, where he worked with hempcrete as well on a sort of, I would say, sister project on a much bigger scale than ours, but again, going in the same way of looking at combining traditional building techniques with hempcrete, doing it in a slightly different way than we did, but it made for a very enriching experience and information exchange on techniques and approaches and so on. So here we see the foundation lifted off the ground from the timber with the hempcrete coming in. So as Anna explained, hempcrete can be used both in walls and in floors and in roofs. So in this case, it's coming into our deck. There, the main superstructure is almost up. As you see, it's not a very big building. So we have the poplar, which you can see forming the walls, and then glulam, which is manufactured in Flúðir, not that far away from where the site is. Yes, and of course we had a traditional celebration, so the carpenters always recite a little poem and break a glass of champagne in celebration where the main structure goes up, which we duly did. And here we see the setup and the beginning of doing the hempcrete walls. So it's a very simple setup. In this case, we just used a cement mixer, a concrete mixer, which you can see over there. And it's sort of, the process is like a human chain of sorts. So you delegate particular tasks to particular people, and it's good to keep that in that motion so you have consistency as the building gets built. So here we have buckets of the shiv, water, and then lime towards the top, and would mix these in batches, transport them to the person who would be casting the walls, which is Georg in this case, and so on. We were blessed with a very good summer that summer, so we had sort of non-stop sunshine from day, basically. But again, we're lucky in this case, but these are the limitations of using this method, obviously, when you do it in this way, because it's not always sunny in Iceland, as we know. That said, of course, you can protect it, you can erect a tent above, there's ways of working around it, but it is the sort of low-tech approach. The other one being doing it sort of in a prefabricated fashion where you could put the elements and erect the elements together in a workshop or a factory setting and then bring them to sites and erect them there, which would ease and speed up the construction. That being said, the actual hempcrete walls came up in, considering it had some trials and tribulations, a week and a half, they were up pretty much. And this is not having a very big team on site. So here the building is slowly coming into view. You see on the left is, this is the east-facing wall, which is also the prevailing wind side. So purposely with this project, we wanted to try different ways of finishing the building, which in this case were the shingles, where the sort of winterly wind is the strong lime whitewash on the walls, and but you see the exposed wall hempcrete there around the lamp. We see here the seaweed screens already in place, and and the general finish of the little prototype. So So here are some details. And again, this was very much a journey of love and passion, and most things being bespoke, including our very bespoke small door, which Basti had to scratch his head in order to make it workable. So it actually has stainless steel rods holding it in place so it doesn't warp, given that it's exposed to the elements, and a sort of pivoted timber screen that acts both as a sort of privacy screen from the main road as well as a bit of a windbreaker that kind of swings in and out and forms an integral part of the building. And of course the production. So it was very much a case of exchanging knowledge, but also human sort of generosity. So through our professional contacts, a joinery workshop nearby was very kind to let Basti use their facilities, where he was able to do all the kind of detailed joinery work, which he very much relished. So here you see the screens in motion and coming up. Here are the window frames, and it was very much a labor of love. And here we have Alberte Boyesen, our collaborator on the seaweed screens, who is a product and a textile designer, but who, through a number of residencies here in Iceland, started experimenting with seaweed. So, and we heard about her, and we approached her with this idea, which she loved and jumped straight on. And our collaboration is still continuing, but here you see the screens being made and coming together. And this is all the same type of seaweeds gathered locally. The color differences simply arise from the fact of when they were harvested. So the greener or sort of lighter looking ones are harvested in the spring, and the darker ones are in the winter, just due to photosynthesis and different biological processes that happen. And here you see the kind of stained glass effect that we have on our sliding doors.
Yeah, and maybe just to jump in to explain about the screens with the Japanese influence, because if you remember these karate films where they have these paper walls and you kick through them, it's basically the same, but obviously we don't have rice in Iceland, so hence we're using what we can, which is seaweed.
Yes, but lending the idea of a kind of privacy screen, basically. And so this is just over a year ago. So here the windows are in place. Most of everything is pretty much in place, and we are rendering with Davi, an amazing local craftsman. So the render here, in fact, it's an English mix, which is a medieval sort of recipe that was rediscovered recently, being seen somewhere on a half-ruined manor where they saw how well it weathered. So it's a mixture of fibers, chalk, and lime, and it's a breathable material. So very important part of building with hempcrete is that you need it. You don't seal it off. You need it to leave vapor open, so vapor can escape. So that they need to work in concert. And here you see the building in its more finished form. So it survived one winter already, and seems to be doing quite well. But also, as part of our approach to it, is installing measuring equipment. So we've installed probes into the walls and the floors to monitor its performance with time and with seasons, and also the fact that it is only heated by a simple wood burn stove. So we are able to simulate different scenarios when it's completely cold outside and unheated space versus heating it up, how quickly it heats up, how quickly it cools down. And we'll be doing this for a year minimum. We want to extend it further to see its performance, to demonstrate how this material works in this country, and crucially make the first steps in making this a wider reality, so that it speaks for itself. Yeah, that pretty much wraps it up. Here it is, standing. And
But just to say that this is only the first step. This is not the end of the story, because our hope is that the building material performs as we planned, with the data to back it up. If it does, the consequences, we believe, can be profound. There are still hurdles to overcome, technical, logistical, and legislative, with the building regulations and such, to be able to make hempcrete at larger scale a reality in Iceland. But from what we know, building with biomaterials such as hempcrete could be decisive in helping the Icelandic construction industry transition into a more sustainable and self-sufficient future. One where locally grown, processed and fabricated materials reduce our reliance on solid concrete walls clad and lined with imported synthetic materials. So that's our mission.
Thank
Step
you.
by step. Thank you.
Thank you both for this wonderful talk. I guess there are some of you that share with me that we, of course, all of us want a house like that and just like move away from society as it operates at this moment. And obviously you've solved the Icelandic housing problem. You know, we just now grow our own houses and get our governments to take their focus from tree planting to hemp planting. Do you have any questions for Anna and Jan? Maybe I can have one of those and you can share that one. Thank you. Can you hand it back, please? Thank you.
Did you have to put an iron in it,
No.
this house?
Just the timber structure.
Okay.
I wanted to know the R value of the walls compared to concrete.
So these walls are about, I can tell you the U value, so it's 35, 37, I guess, centimeters thick once you include the render. So, you know, thick but not crazy thick, it's about 0.18 WMK.
What the R value would be?
I'm not sure what the R value is.
But it would be better, better performing than rockwool.
Yes.
I'm not sure if I missed that, but did you get the production of the chives done here in Iceland, or did you do them by hand, or how did
Production
you
of what, sorry?
The chives, sorry, the herds.
Yes, no, so the shiv itself we had to import, so we did try to grow it, that didn't really work out, but so for this project it was more about proving that the material can work, so we imported this one from England, from Yorkshire.
If I can, yeah.
No, go for it.
So that means the hemp that you grew on site would have technically worked if you had had a decorticator.
Precisely. So it did grow, and we harvested it, but we didn't manage to process it.
Okay, thank you.
One more question over here.
Yeah, I just wanted to ask how the rock wool came into play if the hempcrete is already insulating.
Yeah, so because we wanted to insulate the floor with hempcrete, so we raised it off the ground, and because the alternative would have been to cast in sit or like staðsteypa the foundation, which we didn't want to do, but we were limited with the building height being 2.5 meters. So if we had used hempcrete, the roof would have been thicker, and then the internal height would have been considerably lower.
So it was a balancing act, basically, just due to the sort of spatial restrictions.
Ideally, we would have used hempcrete.
Yes.
Hello.
Hi.
Thank you very much for what you're doing. How much?
How much?
Good question.
Excellent question.
Yeah.
I can't tell it with sort of great precision. We need to sort of go over it, but we estimate sort of around what, 7 million, circa about possibly 7 to 10, let's say. Let's give a range. Yes, that being said, we did work it very effectively. So of course, you know, once you take on a sort of commercial stance, it's a different story. But we did, like, as a simple sort of like-for-like calculation, taking the price of shiv and kind of all the ingredients as in to make hempcrete based on the imported elements, it's pretty much comparable to, so a cubic meter would be the same as a cubic meter of concrete without the reinforcement.
And that's not allowing for import. So we were dealing with really high import costs, which really drove the cost up. So, and this being a prototype, it's always going to be more expensive, but it's to prove the point that it can be done. And then in the future, once it picks up, the costs will go down. I mean, the hemp itself was really cheap.
So that's 50,000 euros approximately.
cost.
And also
cost.
bearing in mind that there's economies of scale. This is a tiny building, but of course the amount of time and effort, that went into it, let's say it inflated it. If it was a bigger building, of course it would level out. So
It's
hopefully-
tiny, but we all want one.
Yes.
Yeah. Well, are there any? Oh, there's one more question over there. Could you please help passing the microphone? Thank you.
Hi. Any idea how long such a house will last? I mean, there have been built other houses in other countries. How long are they lasting? compared to other
Well,
houses?
yes. I mean, I think it's a case of if maintained well and taken care of, it will last as long as it is maintained. It's, in terms of its taking care of the exterior finishes, maintenance, it can last as long. I mean, it can last forever. Of course, you've got cases of timber buildings in Norway, going back many centuries. So, yeah.
It is a very strong, very, very strong material, isn't it?
Yes, it is. But this is because hempcrete as a building material has been really well researched compared to other natural building materials. But one of the things that is still or sort of more uncertain is the freeze and thaw, how that affects the hempcrete, plus the longevity, how long it lasts. So they started using it in the 80s, late 80s in France. So we have at least that time scale that it has lasted.
We're building from that time.
Yeah, thank you.
We have time for one more question. Thank you.
Yeah, maybe a little bit like comment and question. Yeah, so amazing project. Thank you for it. You mentioned the rock wool, but you could also use the hemp insulation, but it's probably not allowed to import same as hemp. So it will even like increase the cost. Yeah.
Precisely.
But like you could do it with insulation.
Exactly.
Yeah.
And
And maybe like to answer or add something to your question, the good thing on the hempcrete is that the lime kind of became the limestone again in the material when it's become like ready, when it's like dries out and processed in like 2 months from you build it, maybe here like 3 months. So it can really last very long. And this is a great thing on the limestone, and it's also good like if you don't want to use it or you want to extend, you can always break it down, mix it with a new one, and then go again, yeah, like 50-50. So I think it's not quite often mentioned, but like the hemp lime, we don't even like call it hempcrete in the hemp word. Or some people already created this word hemp lime because the hempcrete associated with the concrete, which is not really the association we want to use. So if you want to make the other hamsters happy, try to use hemp lime, because I think it's just, what is it, like hemp and lime.
yeah, well, we thought for the context of sort of introducing it as a material, it's easier for people to understand hempcrete at this stage, but I agree with that point. And also just to say with the carbonization process, that like you say, the hempcrete walls, they carbonize because they are taking in the carbon from the atmosphere and turning, sort of solidifying over time.
It's another case of, as a sort of carbon negative material, it continues to absorb CO2 even already as a building form, basically.
Well, thank you. Let's thank Anna and Jan. Thank you very much.
Thank you.
Yeah.